Maybe just send.
I sent the picture of the receipt, so
Okay, what was the homework last week?
Come, let's go through the homework. It's
What? Yeah, I did.
I was doing research at all.
I did. How would you say yeah I did in petition sense?
I don't know. I only say no. I only know how to say no.
No.
Sorry for the decision.
Alkenes revision. Did I give you the answer key? I did, right?
That's okay.
Okay, cool. Can I just go through the ones you guys have question, then I can go into Ionic Equilibria? We don't have enough time to go through so much. Yay!
Because my teacher's really fast.
No, I haven't even watched.
Your teacher always very fast, oh. Last year also, right?
Teacher's not my teacher. Yes.
One, I have not a single fluent about. So.
Oh, fine.
Really?
Yeah, it's a lot of PH.
It's kind of like chemical.
Which one do you need?
I don't need the structure questions. I need the MCQs. Do you have any structure questions?
Let me see.
Wait, is your school revision back? Sorry.
No, no.
No, I don't.
Well, you know where are we? We are at the
Yeah.
yes.
I don't need any for structure.
So no question, huh? Will we have questions?
For structure.
Okay, come, let's go to the MCQs. You MCQ have questions, no explanation, right?
No, I did his work this time.
Really? But then you all come.
Yeah.
So sad.
When? Oh, sorry.
I also very open answer. I'm so clumsy today. One question. Question 2. This structure. Which of following is not a possible product form when build one in reacts with IBR? Okay, so question.
B. Yeah.
Oh yeah, but this is going more electronegative.
Don't know.
And this build one in, right? So they say not possible when you react it with IBR equals. So do you remember the mechanism?
Electrophoretic efficient.
Okay, do you all know how to write the mechanism? Practice now.
Can I borrow a piece of
Yeah, just take this pen.
Do you want half?
Finish right.
I'm strong.
I say.
Whoa, why is it the tape down?
Oh yeah, it is. Okay, no, just take another.
um,
Okay, you need to consider, right, between iodine and bromine, which one is more electronegative.
I need to see how many. I can read it right. But how? Which carbon do you know it goes into? It goes into it. No, right, the right. It goes into that.
So which one will add in first? Huh?
Oh, is it not bromine?
It attacks iodine, the electron deficient one. This is electronegative, right? So electrons get attracted towards bromine, right? So this is electron deficient. This is electron rich, right? Now the double bond is electron rich, so it will attack the one that is electron deficient. So the one that it attacks will be added in first, okay, in your slow step.
He says it's not like just because a bromine is more electronegative, then it gets added.
No. It's what your electron rich double bond attacks. Okay, this is electron rich. It will attack the electron deficient. Okay. So when you add in, right, iodine is the one that will enter first. Okay, usually most of the time it will. This one is your majority, right? By your Markovnikov's rule. The majority will be here, but okay, you have a small minority where the iodine adds on this side.
So it's like the hydrogen is attracted to the one with more.
That's if you use something with hydrogen, but that one is just a guideline for you to remember. But the actual rule you want to remember is it will create more alkyl groups. That's why when you quote why this is a majority product, right, you cannot quote that the rich gets richer. You have to explain that this creates one more alkyl group. Understand? So one more, you see here in this case, right, you have two electron donating group to stabilize this positive charge. Okay. So when you have two electron donating group, then they will stabilize this positive charge. If you look at the minority, right, it will be like if you cannot see, let me know. Sometimes I'm not looking at the screen. So if I add the iodine on this side, right, you would have been like that. Then you land up with only one electron donating group. Hydrogen is not electron donating group. So you'll find that it's short. Follow? Okay, so this one is the minority.
Wait, so when the iodine is the first carbon, it's majority.
When iodine adds here, right, it creates one more alkyl group. You see, is this iodine attached to this carbon makes this an additional alkyl group. If iodine is added to this carbon, right, then we didn't create the alkyl group. We only have one alkyl group. So this is only one electron donating group. You understand? Okay. So when you have to explain this in structure, you can quote the rich get richer. You can say using Markovnikov's rule, okay? Adding iodine, okay, to the first carbon creates an additional electron donating group, okay, that helps to stabilize the calcium. Hence, this is the majority product. Okay, so if you look at the options, right, the one without the iodine is actually the one that's wrong, lah, which is B.
Oh, because the iodine will always be added.
Yeah. Okay, between A, B, C for question 2, which will be your majority? But okay, correct. Actually, something else, but they didn't show it. If I want to be really correct about it,
It's just iodine.
no, but it will be. This will be the actual majority they didn't show.
So it's almost first because it's like it's
undeficient. Cannot say it's OMR. So is what is your species? Okay, this species is between iodine and bromine. Okay, it's actually the actual majority because at this step after you have this intermediate over here, right? Okay, you have the options to add it to this positive charge here, either the OH minus. Okay, if you don't write that H. Oh my God, should be. I want the O on this side. Either the OH minus or Dr minus to join in. But OH minus, you all remember this word nucleophile? All those things with a negative charge, usually they are the nucleophiles. Right? They seek for positive species. So between these two, this is a stronger nucleophile. So technically, this will add in faster than the bromine. Later you will later you will learn the strength of nucleophiles. This one and cyanide these are the strongest in the syllabus. Well, I am writing this wrong. It should be. I was right. My bad. It looks fun. I wrote whole. No. Uvia, okay? Follow?
Yes.
Okay, what's the next question while you are writing? I look at it first.
seven.
7.
You have a question about that?
I have I just need geometry, but no. Like I just need an explanation.
You want to listen to it? It's just you have to find out.
Oh, this one.
Okay, then number 7. Can we change the casting to custom diamonds? Oh, come on. Oh, come on. Seriously?
Oh, it is estimated to either 8 minutes. 8 minutes. It's supposed to be like, normally we actually do this. And if you give us the name of the driver is Abdul.
Raman? No, usually Abdul followed by Raman. Okay, come, next question. Question 7. In which of the following is the inorganic reagent acting as an electrophile? Okay, so if you look at option A is electrophilic. No, it's not. It's free radical start, right? Why not? Okay, so it's wrong lah, right? Because it's FRS. Option B, what kind of reaction is this?
Substitution.
What kind of substitution? I think I'll teach this. Did I teach this? Did I finish halogen derivatives with you all? No. Okay. This one is under halogen derivatives. It's nucleophilic sub. Okay.
I feel like you did
I
we didn't go through the mechanism.
Yeah, I think so. We didn't do mechanism. Okay, so nucleophilic sub. See? It's nucleophilic add.
Indeed.
If A, B, C is wrong. Okay, but you can tell correct or not? Alkene plus HCl. Even if you don't know everything else in ABC, you should be able to tell D is electrophilic add, right? Correct or not?
Wait, what's C?
Nucleophilic addition
Oh.
is a later chapter. Okay, next question.
Do you do all 34 MCQs?
Yeah, I struggle. Do you have any questions?
I think you did like 17. So.
I need questions.
You need 17.
Okay, get 17.
Does Ovia have any answer?
Yeah lor, we have no question. Never do right. Okay, I don't watch her. We are gonna do it. Okay.
Order. Like,
I need question 6.
did you
Question 6.
You can check. Wait.
Then they didn't include
They didn't give me my drink.
You see the receipt? I think maybe you didn't add.
it.
So the first order you did, and then the second order you did.
When I gave it, she should have put the same thing.
Oh, it says ice lemon tea. You should complain.
I don't know the complaint.
Wait.
Or add.
You did really?
Yeah.
It's not often.
If you can take my afternoon tea instead. It's quite nice.
Is it sweet though?
Yeah.
Oh really?
Yeah. You open, you see the one in the red, dark maroon packaging. Have not?
Does it taste
Is
like?
it behind? Yeah. That thing behind.
Wait, is there only one? Was it for you?
No, I think still got some. I just haven't go and chill it. It's quite nice. You'll like it. It's like it's Japanese red tea.
Wait, you just had a sign. How did they forget?
Mashed potato either? What do I do?
You go to the app and you just complain.
I don't know how to.
Wait, we pay money though. Is it like saying?
Yeah, probably either with you or they will send again. Okay, anyway, Uvia has question 6. If you want to look at it, you can look at it. If you are too bothered by being cheated by Deliveroo or stuff, then you can watch the video. Okay, so this is the compound shown in step 1, and then they show in step 2. It becomes a very, I can't even tell what is it. It looks like there's a ketone in it. Okay, so it becomes something that's X. Then the X became this funny thing. C.
Okay, wait. I need to have to complain. Give me a second.
C double bond O. CH2. C double bond O. OH.
You got mashed potatoes, right?
Yeah.
Okay, there you go. 1, 2, 3, 4. 1, 2, 3, 4. So the number of carbons is the same. Right? But then there's this part here that became a ketone, right? That means, right, this step, right, water was added. So that if you have an OH here, I think this one will be hard because you all haven't learned oxidation alcohols. So you might find this a bit hard. Okay, but I will just tell y'all lah. Okay, so this double bond, right? Okay, you're gonna add across. You're gonna add an OH here and an H. Okay, what's the condition? What's the condition and reagent needed to add water of this double bond?
Water.
Yeah. If you look at this, you sending email, huh?
One.
Okay.
You can actually report. So
You share like what photo? The thing is not even here. How can I take picture of something that's not existent? Right?
I can't submit the control photo, so like.
I just kidding. Should be an S. I can be an S when it comes to these things.
Since I can either get delivery credit, which is immediately approved, or I can have refund, but it can take up to 10 days to process.
I think refund's okay. I'm okay.
Serious? Yeah? Okay. It says you'll receive an email with an update on your refund request within 24 to 48 hours. Sorry. I don't know how they messed it up.
Can you tell which rich
The numbers are here. So
Yeah, okay.
the first
Yeah.
Tell me what is the reagent condition needed for this step.
H3PO4
3PO4
Concentrate the H3PO4 and heat. That's it.
70 ATM.
7 ATM some more.
300 degrees.
300 degrees some more. Yeah, only giving me the condition. What's the reagent?
Oh, steam.
Okay. So after this step, right, okay, this one I'll give you, okay? In order to get from here to here, right, it's an oxidation of an alcohol, which you all haven't known. I might be missing something. Oh yeah, and I was like, why this carbon look weird? AH. Okay. So from here to here is oxidation of an alcohol. Okay, you all haven't learned yet, so I'll just briefly mention, okay? This is what we call a secondary alcohol. Okay, can you all tell what is secondary or not? Okay, because there is one H only and two groups. Okay, secondary alcohol undergo oxidation using KMN4 acidified, then you heat. Okay, you will change this group to an ketone. Okay, this group here is called ketone.
We haven't done this yet, right?
Haven't. You learn after halogen derivative. So if this oxidizes this, right, then this one you can do reduction. You'll learn later also. This one can reduce back to this one.
Okay, so this is which product? This is N?
Hmm?
What is this supposed to be?
This is Z. I'm question 6. This is question 6.
Oh, okay, sorry. This is question 8. I remember question 17, bro.
17 is this one. Went through already. Okay. A you should know. B and C you don't know, but D you should look at it and know it's the answer.
The answer is B.
Boy?
17.
Oh, so I thought you were talking about 7.
Oh.
Okay, 17. 17. Okay, compound M C6H8 gives compound N on oxidation. 1 mole of M reacts with this on which of the following is an M? Is CAH8 or C6H8? I can't think. C6H8. Okay, this is M. Oxidizes to C4. Oops. Oxidizes to C4H6O4. Okay, so you notice, right? They lost carbon. So it's likely that you have the one of those double bonds at the ends of the compound. Right? Okay, then they still 1 mole of M reacts with 2 moles of hydrogen. That means there's 2 double bond. Okay, so they ask you which is the structure of M. So okay, we look at them one by one. Okay, the first one, right, is CH2 double bond CH, single bond CH2, CH2, CH, double bond CH2. Okay, so if you let this undergo oxidation, right, you cut off. Okay, so you have 1, 2, 3, 4 carbons, right? And then the both ends will become carboxylic acid. Okay. So check the formula. 4 carbons done. We have 6 hydrogen have, right? And we have 4 O. So A is the possible answer. Okay. If we look at B, 1, 2, 3, 4, 5, 6. Okay, so B is a hexagon, right? And then it has like this and this. So if I break off, this half will become carbon dioxide and water.
Wait, I still didn't count the carbons beforehand. So this is not possible because M only has 8 carbons and this has 10 not 10 carbons, 10 hydrogens.
1, 2, 3, 4, 5, 6.
No, like for M there's 8 hydrogens for this.
Oh, it's 10, huh?
Yeah.
Oh, I see 6. I see. Okay. Okay, so it's 8. Looks like 6 to me. Okay, so C8. Sorry.
No, C8. No, it's 6.
Oh, 6, huh?
No, I'm H8, yeah. I was just saying that this is not possible because M has 8 hydrogens and this has 10.
Ah, okay. So,
So-
M is C6, H8 lah, correct, right? This
Yeah,
C
yeah.
only. Okay,
Wait.
so this is still C6, H8.
Also-
Okay, so anyway, this is the when you cleave B, right? This side will give you CO2, H2O. Then this side will give you the same compound as A. Okay? Then for C, it will give you a lot of carbon dioxide and water, right? Because they all break down into like ethane dioic acid, right? So you got a lot of CO2 plus H2O. Then if you look at D, y'all know how to cleave D? Y'all try drawing the product for D.
I think I also need 16.
16? So long. Geranyl, blah blah blah. Upon oxidation, they yield this. It neutralizes completely 2 moles of NaOH in acid-base reaction and can be oxidized under vigorous conditions to CO2 and H2O. Give me a moment, I copy down all the things that I can talk about it. CH2, CH double bond C, CH3. Okay, I tell you how to look at one first, then you all figure out the rest. CH2, CH2, C, CH3, double bond CH, CH2OH. Okay. Okay, now, if they say that it reacts with 2 NaOH, that means that you have 2 acidic groups. Okay, so oh, that is so useless. Why do they talk about the... Okay, actually the last statement from the H2C2O4 onwards is all useless. I just realized. Okay, it's more of when you break it into oxidation, do you get what they are talking about? Like when you break here, do you get the 3 things that they talk about? Like for example, this one over here will be this one will give you the H2C2O4. And then this one will give you CH3COOH. So this one is wrong already, right? Because there is no ethanoic acid produced. Correct or not? You see, they tell you what it use. CH3COCH3 and the other one, right? There's no...
Give you H2C2O4.
Because this one will become CH2. Sorry, this is a C. On this side, it becomes a carboxylic acid. Then the CH2OH, right, also becomes a carboxylic acid. So this is your C2O. Okay, can I just call it ethane dioic acid? It's ethane dioic acid. And it's just two carboxylic acid attached to each other.
It's just
Which H?
like there's three H's, right?
There's two only. Oh, you mean this one?
Yeah.
Oxidized. This is a primary alcohol.
Oh, wait,
Yeah. Primary alcohol will oxidize to carboxylic acid. If you look at B, right, the first compound will give you the ketone that you need. Also, this part, right, when you oxidize, this will give you the ketone, the CH3COCH3. Okay. Side, when you cut off, again, it will give you the ethane dioic acid. Okay, this one is option B. Okay, now question is whether the middle part gives you what they mentioned. Okay, that means this side has to be a ketone, right? Can you see the compound they gave for you? It's CH3COCH3, right? Sorry, CH3COCH2. But this portion here will become a carboxylic acid because it's a CH. CH will turn into a carboxylic acid. And if you see, okay, fine, there's a carboxylic acid there. This one will give you a ketone. So it's possible that B is the answer. Yeah, that's yours. Yeah.
Do I owe you money?
No, they owe me money.
Do I owe you money? Okay. Thank you.
Okay, so we actually got the both ends of what we needed, right? And these two is CH2. So actually this is the answer already. Is that the answer?
B is the answer. Yeah.
B, yeah.
B.
It's a dog?
B, wait, we're doing 16, right?
Yeah.
Yeah, it's B.
Yeah, B.
So correct answer is B. Okay, so B, B is correct. Okay. So if you see double bond CH means that it will become a carboxylic acid. If you see double bond C with a R group, right, then it will become a ketone.
So other than this one, we've learned the oxidation of this two, right? Any conform. So we try to see.
Okay, question 24. Hydroboration is a method of preparing alcohols from alkenes.
We haven't done this yet. I mean, we haven't learned it.
No, this one is application. It's not in syllabus. No, as in, no. It's an application. Like, based on the information, you need to be able to figure it out.
So, but you said it's not in syllabus?
You don't learn this, but then you need,
Oh.
but your knowledge is enough to figure it out. Okay, in an anti-Markovnikov manner, that means they probably don't give it to the hydrogen with more hydrogen, right? Okay, blah blah blah. Formation of four-membered cyclic transition state where partial positive charge is carried on the more highly substituted carbon. Okay, the alkyl borane undergoes redox reaction with hydrogen peroxide to form alcohol. Okay, so okay, the BH2, then the hydrogen they add. So at the end, you get this compound. Okay. So which of the following will be obtained if the following compound?
It's for us.
What sound is that?
Outside.
Oh my god, that's annoying.
This
What is as soon as the door open? Bro.
Okay, so now when you have a compound that is okay, like that. So this is the one with more hydrogen, right? Let me see, we have H2O. Okay, so you have to think about it. Okay, if I add, you see they say that they use BD3 followed by H2O2 and OH. So okay, we have to think about, so instead of having BH3, right? Okay, I'm now using BD3. Okay, so this is actually to track where the hydrogen moves. Looking at the right place. Okay, so we have to track where does the hydrogen move. Okay, so based on the information that they gave you, right, the hydrogen, the BH2 will go to the one with the BH2 will go to the one with the hydrogen, right not? So my B here will be BD2. Okay, and this part here will be a D when you remove the double bond. So far this okay? Then after that, after you undergo the H2O2 and the OH, what happens? The D here remains, right? This one will be replaced with a OH, right? So what you do is after that we replace with H2O2 and OH. H2O2 and OH. Then okay, your D will remain. Okay, then this part will have hydrogen. So it will have OH.
Why is the OH and not OD?
Because the OH is this step, not this step. The OH comes at the second step, not the first step.
But I mean, like, how can you tell the difference? Because, like, in this case,
Only the first step there's deuterium. The second step has no deuterium.
What?
Deuterium. Heavy water. Hydrogen with two protons. Sorry, hydrogen with two neutrons. You know what's the isotope?
Yeah.
Deuterium is the isotope of hydrogen. So it's hydrogen with two neutrons, which means it's an isotope of hydrogen.
Oh, okay.
So questions involving deuterium is usually to track the movement of hydrogen, like which is the actual part where the hydrogen is being moved. Okay, so can you tell the answer is which one?
Okay. I'm going to 25.
Olivia, okay?
Yeah.
Okay, any more questions? Probably the one that went toilet has question.
I have 5. The next question, 25.
The question you ask all need a lot of drawings, yeah. No, I'm reproducing in my direction first. Because it's too much to write.
Journaling is also Turkish. Like what? Turkish. I see. How is it? It's okay. That's okay. It didn't exceed expectations. You should have got me a taste again. It's a baker.
Okay, so this is the information provided by the question. So what you can tell is that this double bond is removed, right? Kind of. Then they kind of join this carbon here, right? So imagine, so yeah, for questions like this, right, you kind of have to like.
Oh wait, I don't need to. I'm so sorry.
Can I show you? Which time I to reproduce? You know what I do? You know how I to reproduce this?
Yes, I thought this was one question. This was another question. So you need 26? No, I don't need 26.
Please help me boxes.
I'm sorry. I think I'm done. I don't have to.
You're done.
Let me move on.
Are you all done?
You hate Alkenes. I just hate Alkenes. What I do, I hate.
Are you all done?
Yeah. I want to.
Each of y'all take one.
Oh my god. Why is
Take one for Ibra.
What am I looking at?
Okay. Ibra, you'll be getting this big sheet from Shu. Yeah, I guess we'll get it through the mail.
Actually, you can pass to me, you know.
You see him, eh?
Yeah.
Hmm?
Why?
So far. Okay. Same, yours interchange at the same place, is it? Okay. Then yeah, I guess your life is in Shrutika's hands.
Okay.
Okay, come. Okay, before I go into this big fat chart, let's talk about some basics. Let me take out a yellow board. Page 160. Yeah, I'll go very fast with the theory, okay, because I want to go into the calculations. Ready? Ubia, ready?
Yeah.
Okay, no. In the past, right, your basic definition of acid and base is acid give off H plus, base give off OH minus, right? Yeah, A levels, right, you use this definition instead. It's called the Bronsted-Lowry theory. Okay? The definition is acid is something that will donate a proton to another species, which is a base. Okay? So the ability to donate a proton to something else to accept the proton, right? Okay? Makes it an acid. Okay, so they are proton donors. Then the base is the one that accepts the proton, not the one that give off OH minus, the one that take in the H plus. Okay, so this is called the proton acceptor. And there are actually other definitions other than the Bronsted-Lowry, but this one is the one in A level. Okay, then there's a concept of strong acid and weak acids. Okay, so the stronger the acid, right, the higher the degree of dissociation. Do you know what's dissociation? Okay, that means giving off the H plus. Okay, so if it's a strong acid, almost 100% of it will give out the H plus. Okay, we actually assume 100%. Okay, then the weak acids, they will be like less than 1%. Okay, if you see the ratio here, they tell you alpha less than 1. Okay, alpha is this degree of dissociation. Okay, they will sometimes ask the definition for degree of dissociation. Not very often. One of those I actually will see. Okay. Okay, so they give you some example. Okay, HCl being a strong acid, okay, will fully dissociate by giving H plus to water. Okay, then we look at acid as H3O plus. Okay, we look at acid as H3O plus or H plus. Okay, both is K. Okay, we use them rather interchangeably, right? So you can either look at this as H plus, sorry, HCl give you H plus Cl minus, or you use a addition of water to get H3O plus and Cl minus. Okay, both is fine. Yeah, I remember last time, I'm pretty sure y'all didn't use the H2O giving you H3O plus, right? Y'all just split it. Okay, at A level, we tend to use the one with the water. If it's a weak acid, right, then you have double arrow. That means what? Some of them will form back the non-dissociated acid and water. Okay, and if anything, actually your equilibrium lies to the right, sorry, to the left. Okay, it forms back, so you have not a lot of acid, which makes ethanoic acid, in this case, a weak acid. So far, y'all can follow? Okay, okay, now strength of acid is defined in terms of the degree of dissociation and not concentration. Okay, concentration and strength is different. Okay, you can have a very, very concentrated acid, like for example, a concentrated ethanoic acid, but then your dissociation is still very low. So even having a concentrated ethanoic acid wouldn't give you a lot of H plus. Okay, whereas strength is the extent that they can give off the H plus. Okay. Okay, first formula. Okay, from now on, anything you see has a P, right? Okay, be very, very familiar into your bloodstream. Okay, that having a P means negative log of what this value is. So, for example, pH means negative log the concentration of H plus. Okay? So, for example, if I say pH 7, that means the concentration of H plus in water. Okay, you can reverse it in a way. So, if you want, you can. Did you give me? Yeah, okay, right. Okay, so if you want, you can copy this. Concentration of H plus, okay, is equals to 10 to the power of negative the value of pH. So for example, water being pH 7 means that the concentration of H plus in water is 10 to the power minus 7. Cool.
It looks so short here, but like the lectures were like 2.
2 weeks. That's quite short.
Really?
It's actually quite a big
Like
chapter.
the notes were very long.
Quite a big chapter.
Oh wait. It's so long. It took so long. Yeah. Really?
So if you look at the pH scale, right, hence you know why, now you know why, just now you all used to wonder, right, how come the smaller the number, the more acidic, right? If pH is a measure of acidity, why would smaller mean more acidic? Because of this. Okay, it's to a power of a negative value. So the smaller the pH value, the more acidic. The larger the pH value, the less acidic. You follow? Yeah. Okay, pH value depend on concentration and the degree of dissociation. Use of pH in measuring the strength of acid is limited since the value changes with concentration. Okay, so the pH of an acid increases upon dilution. Why? Because if you look at the equilibrium on this side, right? Okay, can you see here? What happens if I add more water? What does the Chatelier principle tell you?
Position of equilibrium.
Shift where? Okay, let's look at this one easier. Down with a double arrow. Okay, when I dilute means I add more water, right? So when I add more water, what happened to the equilibrium in example 2?
To the right. Right, yeah.
You should have, then what happens? You have more H plus, right? So having more H plus actually will increase your pH, right?
Having more H plus decrease your pH. Because acidic.
But then you although you dissociate more H plus, but then it's also in a larger volume. So your concentration drop, ma.
How does that increase the pH?
One can just write. Hold on.
No, increase pH. It's slightly, but it's less acidic.
Okay, either way, as you dilute, right, the pH will always merge towards 7. Okay, so if you look at this page on this side, right, okay, you can see pH in measuring the strength of acid, okay, is limited with the changes in concentration. Okay, pH of an acid increases upon dilution, okay, at constant temperature to a volume V. Similarly, the pH of a base will decrease upon dilution at a constant temperature to a volume V. Okay, so this one will give you a relatively high pH value, and this one will give you a relatively low pH value. Okay, this one not important. If ever come out, it will be MCQ. Okay. Okay, then here comes the important word: dissociation constant. Okay, dissociation constant is just another type of equilibrium constant. Do you all remember what's the equilibrium constant? From chem equilibria, right? Correct. Every equilibrium has their own equilibrium constant. So in this case, we also have different equilibrium constants for different acid and base dissociating. Starting with the first one, okay, we have an acid dissociation constant Ka. Okay. Usually this is it is very different from chem equilibria. You won't be doing the like when you add and then you do the ice table and then you calculate the Ka. Okay, it's very different. You won't be doing this. This is usually like they give you pH, you find the Ka, or they give you the Ka, you find the pH. Okay, so for any equilibrium, it's actually exactly the same definition. Okay, for this equilibrium, your Ka is given by this. Okay, then ignoring water, you can see water is taken out of the Ka expression. Okay, okay, you technically, I would say you don't need to memorize this. Okay, the thing that you need to memorize is coming up next. Okay, but knowing that helps you to derive the other formulas. Okay, so the next page, okay, remember I tell you anything that has P, right, means you are gonna do a negative log on the value. So pKa means negative log the value of Ka. Okay, so the larger the value of Ka, the smaller your pKa. Okay, so if you look at this little table of examples they give you, right, you can see that as your Ka value decreases, your pKa value increases. Okay, so they are inversely related. Understand? So smaller pKa means stronger acid. Larger pKa means weaker acid. Everybody follow? Okay. Okay. Then we talk about the multi-basic acid. Okay, can you see that okay, last time, right, remember you all do something like sulfuric acid react with HCl. They cannot assume that all H plus react to that at once. Okay, but it's not exactly that. Okay, it's like you each acid molecule, right, have to give off one proton first before they give off the second proton. So the dissociation also occur in the same way. Okay, every H3PO4 to dissociate one proton first before they dissociate the second proton from H2PO4 minus. Okay, and then in order to dissociate the third proton, then your H2PO4 2 minus will each dissociate the last proton. Okay, and as you can see, that is it easier or more difficult to dissociate the protons after you have done so? Harder. Your Ka is smaller. No. The smaller the Ka means the right hand side is less likely, right? That means the forward reaction is more difficult. Okay, as your Ka value decreases, it means that your forward reaction is more difficult, which makes sense because you think about it, right? You are trying to take a H plus out from the acid, which is already negatively charged. It's always difficult to remove positively charged from something that's already negatively charged because they are trying to hold on to anything that's positive, you see. Okay, so it becomes more and more difficult for subsequent dissociation. Okay. So then okay, so whatever I say is explained here already lah. Okay, in this paragraph over here. Okay, now moving on, the another example, okay. Given the pH of 0.5 solution of weak acid is 4.5. Okay, so if you have the pH, you can find concentration of H plus. Right? Just now we learned the formula, right? pH equals to negative log concentration of H plus. H plus is equals to 10 to the power of minus the pH, right? So this is 10 to the power of minus 4.5 for concentration of H plus. Okay, you can see the first line they calculated for you already. Okay, then what did they ask for? They asked for the Ka, right? So what you can do is H plus and A minus, like you've been doing in chem equilibrium, have the same concentration. So you can square them. Okay, H plus and the A minus, okay, they have the same concentration. So you square this. Okay, then we assume that the amount of acid, right, okay, 0.05, right, remains unchanged. Okay, because the amount that is lost to become dissociated is negligible compared to the amount of acid present. In other words, this value 3.16 times 10 to the power minus 5 is negligible compared to 0.05. Okay, so assumption here is these two are the same, and this one you ignore the amount of acid dissociated. This will allow you to find Ka. So far can follow? Okay, if you cannot remember what I say here, most important, okay, I jump a bit, you go to the next page. Did they give you this? Let me see.
Is it good? Why does it taste like? Is this a lot of sugar? Yeah. Oh. This is the stuff This is the stuff you put milk in and then it becomes milk tea.
Yeah. Okay, so this whole, you don't have to like do write all these stuff. You can actually use this formula. Okay, concentration of H plus equals to square root Ka times C. Okay, this is actually long story short of what is going on here. Okay, so if you don't believe me, you can try. Okay, they ask you use this formula, concentration of H plus equals to Ka times C. Okay, C being the concentration of the acid. So now if I want to find square root. So now if I want to find Ka, right, I just make Ka the subject here, which gives you concentration of H plus squared, right, divide by C. Okay, you all try calculating using this formula. You see if you can get the K, the same Ka as they gave you.
Miss Claire, is it Ka plus or Ka times C?
Times.
Times.
Okay.
Yeah, shut up. Oh my god.
What's the concentration of H plus in this example?
3.16 times 10 to the power of 9.
You know how to get that value?
Oh, using the Ka that they gave.
No, using the pH.
Yeah. So it's just 10 to the power of negative pH.
Mm. So is your Ka value the same? Okay. So this formula, please memorize. It will make your calculation very fast. Okay, I'll move a bit faster with the Kb, because everything is the same except that for the base. Okay, Kb is base dissociation constant. So if you look at the base dissociation equation, okay, where they accept a proton from water to give OH minus, then this will be the base dissociation expression. Okay, so same formula to get pKb, you use negative log Kb. The larger the Kb, the stronger or weaker the base.
The larger the Kb, the weaker the base.
And the smaller the pKb.
You say pKb or
pKb.
Well, the smaller the pKb, the weaker the base. Isn't it?
The smaller the pKb, the what the base?
The weaker the
Wait, the smaller the Kb is weaker. The smaller the Kb, the stronger the base, right? Then if it's for pKb, is it the same or is it inverse?
Yeah, because it's for base, right?
Remember, the P always got inverse relation. Yeah, you all listen carefully. It sounds like a tongue twister. The larger the Kb, the stronger the base. Okay, the larger the pKb, the weaker the base.
Wait, the larger the Kb, the stronger the base.
Mm.
For Ka.
Same ah.
But
You're thinking of pKa. K,
pKb,
Ka and pKa is opposite one.
Yeah, but over here, right? When the Ka was larger, it was
Stronger.
easier.
Sorry, the larger the Ka, the stronger the acid. The larger the Ka, the stronger the acid. The larger the pKa, the weaker the acid. That's right. The larger the pKa, the weaker the acid. Correct.
Wait, I need like 2 minutes.
so it's the same for bases, right?
Mm.
The larger the Ka, the stronger the acid. Because stronger acid means it dissociates like
More. More to the equation. Equilibrium lies to the right.
Oh, okay. Okay, so the
Just remember that P always makes an inverse relation with their value. Okay? Yeah, okay. Are you lost?
Okay.
Okay, then you answer me. The larger the Ka, the
Stronger the acid.
the larger the pKb,
The weaker the base.
very good. Okay. Now, for any Ka or Kb value, right? Given Ka, you can find Kb. Given Kb, you can find Ka. Okay? What am I talking about? And this is called the ionic product of water. Ionic product of water is concentration of H plus times concentration of OH minus. And it is also, okay, this formula at the bottom, can you see? Kw equals to Ka times Kb. Okay, this formula very important. Either use this, but usually I don't use this. My favorite one is actually to use the 40. Okay, that means, you see here they gave you right, Pkw equals to negative log this, right? So, in general, okay, especially in why I say general, because most of the things that you all deal with is at the temperature of 25. Okay, so you can say that, okay, I better put at 25 degrees Celsius. Okay, pKw is equals to pKa plus pKb.
Time.
Well, time is without the p. Okay. Okay, so now you see this, right? What is this thing about? Okay. So this is ionization of water. Okay, when water dissociates acid, this is called the ionic product of water. Okay, this process is endothermic. That means as you boil or as you heat, right, more water will dissociate to give you H plus and OH minus. Okay, so if you look at the data they give you, right, at 10 degrees Celsius, my Kw is 0.3 times 10 to the power minus 14. At 30 is 1.5, at 50 is 5.5. So as temperature increases, your Kw increases. Okay, but this is just to tell you that, remember, equilibrium constant is only affected by what? Temperature only, right? So this actually justify that point again. Okay, but usually this will only come out MCQ. Okay, the main thing you need is to know that at 25 degrees Celsius, this value is 1.0 times 10 to the power minus 14, and you need to use this value to find Ka and Kv respectively. Then you're like, getting a bit lost already, right? Why the data, the information getting more confusing? Like for example, this is a base correct? So base is Kb. Why do I need Ka? Correct? Because if you look at the equation the other way around, can you see this pH plus here? Technically, this pH plus can also donate proton to water. So the words makes this a what? Makes this an acid. So if I want the Ka value of this going backwards, right? How do I find it? Correct, you use Kw. Understand? So similar story, like our earlier on we had the acid, right? Okay, if we look at this, yes, forward it behaves like an acid. But A minus, I didn't tell you about the conjugate. Okay, never mind. I'll talk about conjugate. Okay, the A minus taking in the acid, right, will make it a base, right? Right or not? This one can take in acid to form back HA, right? Right or not? So when this takes in acid to form back the HA, this will be a base. So you must have a Kb. So how do I find the Kb? A minus can take H. You look at it backward, Pippen. If you look at it backwards, how do I form HA from A minus? How do I form HA from A minus? Okay, let's ignore the H3O plus. It needs to take in a what? A hydrogen, right? So imagine say I use water instead lah. Okay, then it will take H and you'll give off a OH minus, right? Correct. And by taking in the H plus, it makes it a, when it accepts a H plus, or when it accepts a proton, is a, so as a base, how do I get the base dissociation constant? How do I get the Kb? If I have the Ka.
Kw minus
Divide.
divided by
Mm.
K.
When you use Kw, you divide. If you want a minus, right, then you have to use pKw minus the pKa or the Kb respectively. Okay? Okay, I don't know why I didn't have this terminology, so I need to tell you all. Okay. So you all know how this is the acid, right? Right or not? Then it gives, because it gives off the proton, right? This over here, right, is called a conjugate base. Okay, so can you all write here acid? Okay, water is actually the base because it's accepting the proton. Okay, so acid, base. Okay, then H3O plus becomes the conjugate acid, and A minus is the conjugate base.
What does it mean then?
You all know the meaning of conjugate, right? You all did like certs in secondary school.
Yeah.
So it's like it's partner like that in a way. Okay, so HA plus H2O, double arrow give you H3O plus A minus. Okay, so for this one, right, okay, this is the acid. Okay, because it loses a proton or donates a proton, right? Yeah, donate. Enforce your memory on this. Okay, so donate the proton, right? Then the A minus, right, in order to form back the A, this one, right, what happened? It has to accept a proton, right? So accepting proton makes it a base, right? So yes, it is a base, but more specifically, it's the conjugate base because they are paired. Conjugate actually just means that they are paired with this thing. Okay? Like y'all learn complex number, right? Like y'all know if I have 2 plus 3i, the conjugate of this is what? 2 minus 3i, right? Cannot. So that when you multiply them together, the I disappear. So same story lor. Okay? This is the conjugate base of this acid. Follow? So this one, since it's accepting a proton, then this is the base. Okay? Because this is accepting proton. Okay? Then this one, to format the water, it needs to lose a proton, right? Or it needs to donate a proton. So this makes it the conjugate acid. Okay? Conjugate acid of H2O. You all follow? Okay? This terminology very important in organic chem. Okay, because we always use this to explain the species used. Instead of drawing the entire formula out, you can just call it a conjugate base or the conjugate acid respectively. Okay, so it's more of like a terminology you have to be familiar with using. Okay, so now we go to the one with the base. Okay, the one with the base, we have B plus H2O, give me BH4 plus, sorry, BH plus, not BH. I'm thinking of ammonia, that's why. Okay, so now from B to BH plus, what happened? Did it accept or donate a proton? Accept a proton, right? So what does it make it? Okay, good. Okay, so this is a base. Very good. Okay, so this is the conjugate acid. Okay, typical example is ammonia. Okay, that was what I was thinking just now. That's why I said BH4 plus. Okay, so like ammonia with water, then give you what? NH4 plus and OH minus. Okay, so base, conjugate acid. Which you all know, right? Because NH4 plus kind of is an acid, right? Because it reacts with bases to give you so ammonia gas and water, right? Okay, now if this is the base, then the water that is losing the proton is a what? Okay, this is an acid. Okay, because this one will donate. Okay, donate proton. So OH minus will become the, I got my spelling, proton. Okay, so this is the conjugate base. Okay. Lecture will cover this, right? No. Yeah, I was like, why shoe so blur? Never watch lecture. Okay, so now the last bit, okay, the POH. Okay, so POH again is the negative log concentration of OH minus. Okay, so pH plus POH is 14, pKa plus pKb is also 14. Okay, this one, just now I gave you all this equation, right? You can equate this to 14 also. Okay, and take note, only at 25 degrees Celsius. Okay, at other temperatures, the number is not 14. Okay, you're gonna ask me, then other temperature, how I calculate? Of course, to give you the value lah. Only value you need to remember is the one at 25. Okay, ordinary condition is 25 lah. Okay, so now they talk about strong acid and strong base. Okay, strong acid and strong base, we assume full dissociation. So the concentration of the H plus and the concentration of the OH minus is exactly the same as the acid. Okay, that means the actual amount. Whereas the weak one, okay, we will use the formula I told you all to use. Okay, this one. Okay, concentration of H plus is equal to square root Ka times C. Okay, if you are very, very good at math or you work very fast, I ask you calculate pH, right? Then you just straight away apply a negative log to this value to get a pH. So far, okay? Don't worry, we'll do a lot of practice. You'll practice until you vomit. Okay? Then, okay, so if you have, how do you calculate pH of strong acid and bases. Okay, again, we use the formula. Okay, just now I gave you concentration of H plus is square root Ka times C, right? So similarly, if I want OH minus, you want to guess what's the formula?
E times C square root.
Yeah. Okay, square root Kb times C will be concentration of OH minus. Okay, as for strong one, it's quite easy. You just assume full dissociation. Okay, so you just use the original concentration of the acid to find. Okay, for the weak one, then you have to use this formula. Oh my god, I shouldn't have written this here. This one is for weak one. This one is for weak one. Shit. Oh yeah. Okay, please move me down here. I'm then annoyed myself now. This formula should be here. Okay, this formula is only for weak. Okay, for strong, right, we don't need the Kb. Okay, strong acid and bases do not have Kb or Ka. Okay, only the weak ones have.
Concentration is the same.
Mm.
That's right. Is pKa the same as pH?
No, it's not the same. pH is concentration of H plus. That means amount of acid present. Ka, so pH tells you amount of H plus present, but Ka tell you the strength of the acid. That means how much it dissociates.
What did I say? I said pKa, right?
You said Ka and you said
I
pKa
said
and H.
pKa. But
Not the same.
Are they
No, they are not equal. Yeah. Like for example, right, I can have a very strong acid, for example, sulfuric acid. Okay, very, very strong acid, right? So let's say I have very concentrated, so my pH is like 0 point something. But then I can add a lot of water, then what happens? My pH will increase, right? But my Ka will always be constant based on 25 degrees Celsius. Okay? Okay, I will not go to the indicator yet. Let's go to the type. Okay, actually, I do a quick one on indicator. Okay, there's this part on how the indicator works. I will run through very quickly because this part, they haven't been testing the calculation these few years lah. Okay, but basically PKIN okay, KIN is basically the value which the indicator will change color. Okay, so it's like the point where the either the cation ion is dominant or the anion is dominant. So basically the in acidic solution, right, you will have a cation ion which is a certain color. Then you have the alkaline solution which is the anion as the predominant. Then you have another color. Okay, so based on the whichever is predominant, you have the color accordingly. Okay, but I think this one 5 years ago already. They don't ask this anymore. Yeah. The more important thing is this one. How do you remember so many? Okay. I just give you a quick guideline. Okay. If your titration involves using a strong acid, right, you use methyl orange. Okay. If your titration involves using a strong base, right, you use phenolphthalein. Okay. Okay. Then you have a lot of example here. Different kind of titration, right? Okay. The key one you really need to know is actually this page over here. Okay, but I will not go through this page. I go straight into the calculation for you. Okay, now if you look at the big chart, okay, okay, okay. So we are gonna do 4 different kind of titration curves. Okay, so some formula I suggest that you want to like have it at your fingertips. Let's write it at the top of the table. This space over here. Okay, you can start with yeah, I write down a few for you. Okay, you all follow me. Okay, the first equation you want to copy down is pH. Yes.
same for both?
Yeah, I give you all double side so you all can practice it. Okay, this is negative log concentration of H plus. Okay. Second formula you want to copy down is concentration of H plus equals to what?
Ka times C
Square root of Ka times C. Okay. Oh, frick, I cannot do this yet. I haven't teach you all buffer. Damn it. I was like, I want to go in. Oh, still got buffer. Okay, fine. Let me do the buffer first. Buffer.
You know, like that.
No, I want to teach this already. I'm like, I still need to teach this before I can go in.
Very big thing.
Quite big. I was like, by the time I done with buffer, I feel like I cannot do this curve already. Sad.
Buffer.
Okay, turn to page 169 of your yellow book. Another one I do kind of run through. Before I reach this table, if you like absorb 50% is enough already. Okay? When you do the table, right, the remaining 50% will sink in one. Okay? So whatever I've been talking about in this chapter so far, if you only understand 50%, that's enough. Okay, the other 50% you like, not sure, cannot remember, or don't know how to apply all that. Don't worry, the other half is in the tables. Okay?
Buffer is only for papers.
Okay. Sian. Okay, a buffer solution is a solution whose pH remains almost unchanged when small amounts of acid or bases are added to it. Okay, I give you a very good example of buffer. Your contact lens solution. Yeah. Okay, contact lens solution, because it has to remove both acid and bases from your contact lens every day when you soak it, you see. Okay, so that's the purpose of one use of the buffer solution. Okay, so in definition, they do you need a new definition? I would say don't need. Okay, but you need to know the difference between the acidic buffer and alkaline buffer. They are very similar. Okay, they will contain a weak acid and the salt of the weak acid. Okay, for the acidic buffer, for example, ethanoic acid and say sodium ethanoate. Okay, weak acid and the salt of the weak acid. Alkaline buffer, okay, example would be ammonia and ammonium chloride. Okay, you have a weak base and salt of the weak base. So far, okay? Yeah, so this is the example.
Is it always
No, can be other weak bases and salt of their weak base.
like just a salt?
Not necessarily. Can be bromide, can be iodide, can be other anions.
Does it make a difference?
Not really. The key bond is actually the conjugate base. Basically, the acid and its conjugate base, you need both of them. You need the two components. The chloride, all these are just spectator ions. Sodium also spectator ion. Okay, what we always need is the weak acid and the conjugate of the weak acid. And we need the weak base and the conjugate base of the weak acid, weak base. Yeah. Okay, basically we just need the conjugate of them. Okay. So for example, right, if you look at this acidic buffer of ethanoic acid and sodium ethanoate, like I said, don't care about the sodium, okay? If you add acid, right, okay, the conjugate base will remove the acid. Okay, then you form back the undissociated ethanoic acid. So far, okay? So the H plus are removed by large concentration of the ethanoic ions. Okay, then your H plus concentration remains unchanged. Okay, almost unchanged. Okay, then OH minus, when you add, what happens? Your ethanoic acid will remove the base. Okay, so the ethanoic acid is basically the acid itself. Okay, it will remove the base. So this way, right, by removing this H plus and the OH minus respectively, right, then it will keep the pH relatively constant. Okay, they use the word virtually unchanged. I usually use the word relatively constant. Okay, so alkaline buffer, same story. Okay, I have NH3 as my base and NH4 plus as my conjugate acid. Okay, so similarly, when I add H plus and OH minus, they will remove accordingly. Okay, what do you need to know in this page? Basically, they will ask you, this is a buffer. Okay, show how it keeps the pH constant. Then you write the equation. Okay, you write the acid, remove the base, and then the conjugate base, remove the acid, and vice versa. Okay, so mainly this is the equation, the thing they will ask you for this, anything related to this page. Okay, the other thing they will love to ask you, and is considered more difficult, okay, is the second page. Okay, calculating their pH. Okay, and this concept of maximum buffer capacity. Okay, I jump to pH calculation and I go back to MBC. Okay, MBC is maximum buffer capacity. Okay, calculating the buffer of a pH solution. Okay, this sounds a bit intimidating because so many components, right? Correct or not? I got the acid, I got the conjugate base, and then I have the other component, right? So how do I find the buffer pH? So if it's acidic buffer, right? Okay, then we will use the Ka to go and find. If you have an alkaline buffer, then we'll use the Kb to go and find. Okay. I'm going to explain to you how to get a formula. If you don't understand this nonsense here, right? Just make sure you remember this equation. This equation very important. Okay, we will copy this over to the chart later. Okay. So for example, right, if I have an acidic buffer, okay, Ka, we use Ka to write the expression. Similarly, H plus and A minus is the same again. Okay. Is it the same? Oh, probably not the same at this point. Yeah, it's not the same, sorry. Okay, it's not the same. Let me see. Can I did they give you one where it's derived? No, they use the formula. Okay. So this equation, right, okay, is actually derived from applying logarithm on the Ka expression. Okay, y'all see, yeah? Okay, if you want to know the derivation, listen. Don't want to know, it's okay one. It's not important. Okay? But in the event you cannot remember the equation, then you will have to derive lah. Okay? So you see equation, if I apply log on both sides, right, this will give me what? pKa, right? If I apply negative log, this will give me pKa. Then this one will give me what? pH, right? Then I will have log this one over this one. Can you see? So this one is the salt, this one is the acid. Okay, the A minus, okay, is the salt, and then the HA is the acid. Can you see? Hence, that's why the formula, right, is like that. pH equals to pKa plus log salt over acid. Okay, because when I do a log on this, right, I bring it to this side. I bring it to the right hand side of the equation. Give me pKa. Then my H plus, right, I bring it to the left hand side. Okay, you all know your logarithm rule, right? When you log something that's multiplied to each other, they become plus, right? Okay, so this is how the equation is being derived. Okay, cannot remember, it's okay. Just memorize these two equations. Okay, can? Okay, let's copy these two equations onto the top of your table. Okay, so I have here number 3. Okay, we have our buffer equation. Okay, you can just write buffer so that you know it's buffer. Okay, but if some of you are very smart, you all see you know already, so don't need to write. Okay, so pH equals to pKa plus log concentration of salt over acid. Okay, what's the number one mistake in this one? Is mixing the salt and acid. Some of you are going to write acid over salt. Okay, as a student, I always told myself, just remember SAJC. So it's S then A. So I always remember salt over acid. This is how I remember last time. Okay, but very common. Got some school quite annoying. They give you the formula is minus log acid over salt. It's exactly the same thing. Okay, but I rather deal with plus. Okay, so let's keep to this equation. Okay, I think RI also use this equation. Got some annoying school, they go and put minus here and then they swap this thing. So sometimes if you all see the answer scheme, right, if you all see a minus, right, don't panic. Okay, it could be they use the other equation. Okay, can? Okay, so similarly, if you have the buffer version, okay, if you need, you copy. If not, you should be able to see it quite interchangeably, right? The H turn to OH, the Ka turn to Kb. Salt is still salt, but the acid turn to base. Okay, so it's exactly the same equation. Okay, only thing that question never ask you for pH, right? pOH, they'll always ask you for pH. So when you deal with alkaline buffer, right, you always got one more step to do. You must take 14 minus the pOH to get the pH. Okay?
14 minus pOH.
Because pH plus pOH equals to 14.
But usually they ask for
They will always ask for pH. They don't ask for pOH. But when your question, you are dealing with alkaline buffer, you are still using pOH to calculate. So once you are done with this, there's one additional step. You must take 14 minus the pOH to get the pH. Okay? Yeah. Okay, so they give you some example, okay, how to calculate a buffer. For example, okay, you have this amount, this is the acid. Okay? Then you have this amount, this is the base. Can you all see? The sodium ethanoate. Okay? So what you do is, if you notice something, you are mixing solution. Can you see? You're adding 50 cm cube of this with 150 cm cube of this. So what happens is they are both going to have a new concentration. Am I right or not? Correct? The 50 cm cube will now be in 200 cm cube. Similarly for the 150 cm cube. So you have to find their new concentration after they are being mixed. Okay? After you find their new concentration, then you input into this equation over here. So far, okay? Alternatively, I teach you all another trick is, okay, you all listen up, this is the trick. Yeah, so if you all look at this example 1 on page 171, okay, page 171. It's not say a trick or anything, but it's just like a way to make your calculations faster. Okay, so you see how our formula, right, is pH, okay, equals to pKa. Okay, then you look at the question, they gave you the Ka, right? Why not? So you can calculate negative log the Ka value that is given to you. Ka is given already. Right? Okay, then then I have plus log concentration of salt over concentration of acid. Correct. So what I do is, instead of finding the concentration, right, I actually find the number of moles of acid over the number of moles of salt. Why? Because the volume will cancel out. Because they are both over 200 cm cube, right? Right or not? The 200 cm cube cancel out. So actually, all you need to do is find the number of moles of acid and the number of moles of salt. You don't need to go and divide by the total volume. Then you get your answer already. So it makes your calculation faster. Okay? If your math is a bit weak to understand what I just say, then it's okay. You go continue your 200 cm cube, it's okay, right? Okay, I'm just trying to help you all work a bit faster in the exam. Okay? Can? Okay. Yeah. So part 2, okay, 2.73 gram of this dissolved in 250 cm cube of this. See, this one easier. There's no dilution involved, so we don't need to care about. Anyway, either way, like I said, we don't need to care about the volume. We just deal with the number of moles because they're both in the same volume. Understand? Okay. So this one we use pKb. So this is the extra step I'm talking about. Okay, your formula will allow you to find the pOH, but you cannot stop at the 5.05. Okay, this is one of the top careless mistake. The answer they stop here. Then they never calculate a pH. They took pOH the answer. Okay, so please be extra careful when you are dealing with alkaline buffers or anything that is dealing with alkaline. Okay. Okay, any formula that deals with alkaline such as pOH, Kb, just be extra careful. Okay, questions usually don't ask for pOH. They will always ask you for pH. So always take this extra step, okay, to find your pH after you find your pOH. Okay, if you all lose marks due to this, you all owe me a stuff. Okay. Now here's another example. Calculate the composition of the following buffer solution. So this time out is reverse calculation. They gave you the pH. Can you see? The pH they give you, and they say they mix this amount of dihydrogen phosphate and sodium hydrogen phosphate. This one is acid lah. Okay, acid and salt of the weak acid. Alright. So again, you use the formula. Okay, one of the unknown is in this equation, okay, which is actually the ratio of the salt over acid. Okay, asking you for the ratio is also another common question they will ask for. Okay, either that or they give you maybe either the salt or the acid, then they ask you to find the other one. Okay. Okay, next page is the same question except this time round is an alkaline buffer. Yes. Okay, you see before you proceed the calculation, right? Okay, can you see they gave you a pKb, right? Then you see they gave you pH of the alkaline buffer. Okay, don't use the pH to calculate. You have to find the pOH first before you apply your alkaline buffer equation. Okay? Okay, Okay, uses of buffer. This one a bit of memory work. Okay, quick one. Yes, you need to, unfortunately. The blood buffer is the most important one actually that they always ask. Okay, you must memorize these three equations. So please draw a star, 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 and star. Okay, so the components of the of what is in your blood okay, that makes your blood a buffer. Okay, you breathe in a lot of different things, you eat different things, so your blood has to be a buffer to remove any excess acid or alkaline your body doesn't want. Okay, so the components of your blood buffer is HCO3 minus, okay, and the H2CO3. You see these two components here? Okay, hydrogen carbonate and carbonic acid. Okay, so hydrogen carbonate can remove acid to give you carbonic acid and water. Then your carbonic acid will decompose to water and carbon dioxide that you can breathe out Okay, then how to remove base is actually the backward Okay, your carbonic acid will take in the base, give back your hydrogen carbonate and water. Okay, this is usually a 3 to 5 mark question. Okay, depending on whether they want you to have the equation. Usually will have the equation one Okay, so be able to write the 3 equation and explain which component remove the acid or the base to maintain the pH of your blood in your body. Okay, the one at the bottom, less commonly tested. So I know you all have limited brain space. Okay, so priority you memorize the blood. Antacid is not commonly tested, and if they test, usually they'll give you the information, so you can like make this a second priority at remembering Okay, so again they contain component that can remove both acid and base. Okay, so now let's go back to the calculations. Okay, so now we wrote down these three equations, right? Okay, now, I will do at least one calculation today. So you all copy down the 3 formulas I told you all to write. Okay, so right here, we'll write the 3 formulas. Okay, I will broadly categorize the calculations to, let's see, there's 1 type, 2 type, 3 type. 1 type, 2 type, 3 type. Okay, there's only 3 kinds of calculation you really need to know. Okay, I will label them and then I'll teach you how to do each of them. Okay, the first type of calculation, right? Okay, is your buffer. Okay, you must be able to calculate your buffer pH. Okay, the second type of calculation, right, is called, it's not called this, but I call it this. Okay, give you a term. Okay, strong acid or base, okay, in new volume. Okay, don't wonder why this first. I'll teach you. Okay, then the third kind, okay, is your salt hydrolysis pH. Okay, they each take on a different formula or way of calculating. Okay, as long as you can categorize and identify which of these, you should be able to handle your pH curve. Okay, so one is, I'll just tell you method 1, method 2, or method 3. So please be familiar. Okay, so method 1 is using buffer pH. Method 2 is strong acid or base in a new volume. Then the third kind is your salt hydrolysis. Okay, usually your buffer calculation will be these 3. If you really need, there's a number 4, but I don't think you need It's calculating initial pH. Initial pH. Okay, this one. Sorry?
I can't see what you're writing.
Cannot see how come you cannot see
You know, I just thought.
Cannot see
As in, like, half of it is like cut.
So,
Sorry?
one back. Now I'm not sure.
Wait, I don't see anything. I cannot hear her. Repeat again, Uvia.
I think you need to move it like left. I don't know.
Did you pin the my image?
Oh yeah, yes. Okay, wait.
Now you can see.
Yes.
Okay. Okay. So 1, 2, 3, and 4. Okay. I put 4 because by right you don't need 4 Okay, now keep my display board. Okay, now the first example, right, okay, is the first column. Okay, we are gonna do 4 different examples. Okay, you will calculate until you vomit. Okay, I give you all a visualization. Okay, usually I like to visualize. Okay, what is this thing? Okay, a burette. Okay, now looking at this, can you tell me what's in a burette?
Strong base. Sodium hydroxide.
Okay, so now I have NaOH inside my burette. Okay, what do you know about this NaOH? 0.1 mole per dn cube.
MB.
What's MB?
Or B represents base. You see that got one space. Capital M, you all know, you all don't know, capital M is mole per dn cube.
Never.
Okay, you can fill in a mole per dn cube. Okay, fine. If you all don't know this notation. Okay, then we are going to carry out this titration with what's in my conical flask? That thing that I use a pipette to fill it in with. Okay, so inside we have ethanoic acid. So you all can follow? Yeah. Okay, so we will always be calculating the pH of what is inside the burette. So far you all follow? Okay. Now I have ethanoic acid and I am given that the concentration is 0.2 mole per dn cube. Okay, what's the volume present? 10 cm cube. Okay. So we start with the we have also the Ka of the weak acid. Which is the weak acid? Okay, what's the Ka value given? Okay, so Ka equals to 5 times 10 to the power minus 5.
So for this one, we're given the Ka, right?
Yeah, these are all information given to you.
Acid/base.
Yeah, because later you'll be dealing with big base.
So
Now you're dealing with big acid.
sugars in a conical flask is like what we're.
Not exactly. You for all your titration curve, you either get a weak acid or you get a weak base. So correspondingly. Okay, now how do I find the pH? Okay, initial pH is this. Before I add anything, what is the pH? Why is it 2.5?
Huh? You say initial pH, right?
Yeah,
It's here.
you are supposed to calculate. That's the answer.
Oh.
Okay, can you all calculate and see if you can get 2.5? Okay, we start with this one, initial pH.
I got 2.7.
Wow. How do you calculate it?
Root 5 times 10 to the power the Ka times the concentration. Oh wait, I did the wrong concentration.
See, told you.
Yeah, I got it.
Okay, so this is the working for you to get your 2.5. Okay, negative log square root 0.2 times 5.5 times 10 power minus 5 the Ka. Okay, this is what working that is required. This is the working that is required. Okay, to find your initial pH. Okay, so your initial pH is 2.5. I love how the yellow is so bright on the screen and not so bright on my paper.
Yeah.
Right?
Can't even see the yellow.
Right, I can't see, but they're very clear, right? Like my camera likes this color or something. If you're okay with the initial pH?
Yes.
Okay. So now we're done the initial. Okay, we will leave this space over here. Okay, we will leave it blank first. Okay, but we fill in the working here, the one-liner working. Okay, now we will be calculating the pH at what is this quarter V, half V? Okay, I'll tell you how this thing works. Okay, it's just my way of summarizing this chapter for you. Okay, let's write the reaction equation between these two. Okay, if I have NaOH, okay, reacting with ethanoic acid, what do I get?
Sodium ethanol.
Okay.
Miss Claire, I can't see.
How come you cannot see, can you pin my window?
It's cut off.
Oh.
Now I can see it.
Your computer must be very small. Your computer must be very small, yeah. Okay, so sodium hydroxide plus ethanoic acid give you sodium ethanoate and water. Okay, so this is the salt that we have. Okay, usually, right, when you have this kind of salt, right, okay, they undergo what we call salt hydrolysis. Okay, that means remember I told you all this is actually what? The conjugate what?
base.
The conjugate base, right? So if I add this with water, okay, I will have a double arrow, form back the acid, and produce OH minus. Can you see? Okay, so copy this salt hydrolysis equation under the salt hydrolysis box over here. Okay, write the salt hydrolysis here. Okay, the equation is this one. Okay, you can see or not?
Yeah, I can see.
You got pin my window or not as the spotlight?
Yeah, I think I was in a different layout.
Oh, okay. You change the layout to the spotlight one, then the screen will become very large.
Yeah, I changed it.
Okay. Okay, so far can follow? Yeah. Okay. Now, based on these numbers, right, can you all tell me the volume of NaOH I need to neutralize my acid?
Based on which equation? The salt hydrolysis equation.
Doesn't no, based on the reaction equation. Is it 20 cm cube? You all use calculator slower than me. 20, right? Why you all need calculator? Why do you all need calculator? I was like done like 20 seconds ago waiting for y'all to press.
You need calculator for this.
Okay, now pH at 1/4 V. So now we're gonna talk about 1/4 V. What is 1/4 V? Means you add 1/4 of the 20. That means when 5 cm cube is added. Okay. 1/4 V means when 5 cm cube is added. Okay, so what happened? Okay, imagine let's break it down. I have 1/4. Okay, I'm breaking down parts. Okay, so let's say here, this one is my 1/4 V. It better not be my mom. It is my mom. Hello. 还在教书，什么事？不要 prata，不用 prata。不用，他会吃火锅，你不用买 prata。OK，bye。 No, she thinks that my husband don't eat hot pot. So every year she'll be like, I go and buy biryani for him. Because my husband like eat biryani. Then he thinks that he eats nothing but that. So she'll always like, I go and buy this for him to eat. It's like everybody eating steamboat. Then poor husband feel very outcasted. Like, oh no, why am I the only one eating biryani? Everybody's eating hot pot. He's okay, he can eat hot pot.
But why is your
Oh
mom
my
doing
god,
that?
my mom disrupted my lesson. My video is gone.
You're still there, though.
Okay now, wait for me. I'm coming back.
Hey,
See now, my mother disrupt me. Everybody go toilet now.
no, no. The brownie.
In the fridge.
Yeah. Finish everything.
Okay, come back, people. Come back.
We're back.
Come back to me.
Is this yours? Yes. It's okay. It's from Popular. Yeah, it's so big.
Is it upside down in this, right?
Yeah, it's upside down.
Okay.
Now it's straight.
Oh, that part. Which one?
No, I don't want. I feel fat.
See, now you're whining.
Yeah, lor, like you're at teenage crisis. I'm a teenager. Just kidding. Okay, so when 5cm cube is added, right? Okay, what happened? Never disrupt my lesson. Okay. Annoys me. Okay. Good. So when I add 5cm cube, okay, I'm gonna color this portion here. Okay. This is my 5cm cube added. Yes. Correct. Exactly what you just said. Repeat what you just said.
FCM cube of S is
Correct. So what?
FCM.
Why? Because I added 5cm.
1/4.
Okay, correct. I add 5cm cube, right? So the number of moles of NaOH I added is the amount that is neutralized, not the volume. You follow? So this is my number of moles of OH minus, okay, which is 5/1000 times 0.1. Okay, this is also the amount of acid removed. So far you follow? Okay, so what do we have now? I have the salt, right, equals to number of moles of the salt, CH3COO minus. Correct. Originally it's ethanoic acid. Then I added 5cm cube of the base, right? This base get converted to the ethanoic salt. Correct or not? So the number of moles of base added equals to the number of moles of salt produced. Agree? Agree, yeah? We'll add it. Add. Okay. So far, okay? Then what's the remaining portion containing?
Ethanoic acid.
Okay, ethanoic acid, right? So what do I have here? What kind of solution is present here? Dang, 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 very good, it's buffer. Okay, so equation number 1. Okay, so we use equation number 1, get the buffer pH to calculate. You want to try on your own? Tired, just want to copy.
Wait, actually, what do we write? Yeah.
You leave this top part blank. We calculate all this first, then we come back and draw.
Okay. Okay, let's do it. Wait.
Okay, so how do we calculate the pH at 1/4 V? This buffer equation. pH equals negative log Ka plus log concentration of salt over the concentration of acid, right? But remember I told you all the volume kind of cancels out, right? So we just deal with the number of moles, right? So this part here is 5 over 1000 times 0.1. Wow, at the edge. This one is my number of moles of salt. Right? Technically, there's supposed to be a volume lah. Then technically, the bottom also has supposed to have a volume lah. Right or not? But then, what happened to the volume? Cancel out lor, okay? So save you one thing to write. So how do I find number of moles of acid now? Yes. Okay, so we take 10 over 1000 times 0.2 minus, well, already no space here. Let me rewrite this. Okay, let me rewrite this very nicely. Okay, so I have pH, okay, equals to negative log. Okay, my Ka is 5 times 10 to the power minus 5. Okay, plus log concentration of salt, which is 5. Actually, it's just 5 times 0.1. I tell y'all why in a while. I think y'all know already. Yeah, 1000 also can cancel out. Okay, so 10 times 0.2 minus 5 times 0.1. Okay, then below they all have the phantom 1000 which cancel out . Okay, we will cancel out the 1000. Gone. Okay, so the part in red is actually the leanest calculation you can have. Okay, come, tell me. What's the answer? Don't read it off. Calculate yourself. I know you can read it off. I can see you like staring at it right away. Ovia, okay?
I think so.
You think so? And usually when you say you think so, it's not so. Never mind, I will test you the next one.
Oh no. Yeah, me too. You probably just used the wrong. Yeah, I think.
Yeah, I don't like that the GC needs you to use that specific negative, not the operation negative.
My previous calculator, like my normal one, was also like that.
I can't believe that like after so many years they still haven't corrected this one.
Wait, I got a different answer. How is this possible? I got it.
Good.
Yay.
Okay, answer is 3.82.
Oh, I see.
Okay, now at half V, what do you have? What do we have at half V? Okay, I add another portion here. Half V. I add another half V. What happened? Do I still have a buffer? Is the solution neutralized already? I still have a buffer, right? Okay, so before we dive in and do the calculation, actually no, y'all don't copy first. I show y'all something. Okay, so at half V, okay, what happened to my pH? Okay, I have negative log, still the same story, negative log 5 times 10 to the power minus 5. Okay, then plus log. Okay, the concentration of my salt is what? I use half V, right? That means 10, right? Why not? So I have 10 times 0. Then divide by 10 times 0.2 minus 10 times 0.1, right? What do y'all notice about this value?
It's 1/1.
It's 1, right? So this whole thing is gone. So my pH actually equals to what? My pKa. So you just negative log 5 times 10 to the power minus 10. You get 4.3. Okay? So at half V, we have this phenomenon pH equals to pKa, and it was something I skipped just now in the book. I said I'll come back to it. It's called MBC, Marina Bay Center. No. Maximum buffer capacity. Okay? What is maximum buffer capacity? It's actually the point where your buffer is the most efficient. Okay? Easy? Acidic buffer is most effective, okay, when your pH equals to pKa. Similarly, your alkaline buffer is the most effective when your pOH equals to pKb. Why? Because they have the same amount of salt or base, the acid or base, and they are conjugate. So it's the most effective at that point. So if you see, right, at that point, right, it's also the point where you all know the term stationary point of inflection from math? Yeah, it's that point where like your gradient never really change or has the least change. Okay? So hence this point here is called the maximum buffer capacity. Okay? So back to my chart. Okay, what you can write at half V is, okay, you can write, okay, at half V, MBC present, pH equals pKa equals to negative log 5 times 10 to the power minus 10 equals 4.3. Okay, so you write at half V, pH equals to pKa equals to negative log 5 times 10 to the power minus 5 equals to 4.3. So far, okay? So we learned a few things already. We now know how to do buffer pH. Okay, we also can do initial pH. Okay, what have we not done yet? We haven't done these two, number 2 and number 3 yet. Okay, so let's move on. pH at equivalent point. Equivalence point. What's equivalence point?
Endpoint.
The endpoint, right? The point where all your acid or base in the conical flask has been neutralized. Okay? Oops. Absolutely. Okay. So now all of them gone. Okay, all neutralized already. So what happened? We have this one. Okay, the salt, 100% is this salt. Right or not? No more acid, no more base. Right or not? So what happened here? Okay, now we learn how to do a salt hydrolysis calculation.
Number 3.
Number 3, salt hydrolysis calculation. Okay, so this is my salt. Okay, but this salt is not a neutral salt. Okay, this is a alkaline salt. We call this an alkaline salt. Okay, so it will hydrolyze with water. Okay, to give you the acid and OH minus. Okay, so question, this salt hydrolysis equation, does it have a Ka or a Kb? A Kb. Okay, so how do I find a Kb then? Very good. Okay, so we can do a Kw over Ka, correct or not? Then how do I write the Kb expression? Is this times this, right? Okay, can I say this is square because they are same? Okay, so I write this as square because this and this are the same, right? Then, do I need to care about the water? No, okay. So this over the concentration, CH3, COO minus of the salt. So far, okay? So from here, right, what am I trying to find again? I want the pH, right? To find pH, what should I be finding? Very good, okay? So we want to find the OH. Okay, how do we find the concentration of the salt? Should be quite easy, right? It's the number of moles divided by the new volume. Try not. That means the number of moles of acid I have initially, which is 0.2 times 10 over 1,000, right? This was the number of moles of acid I have initially. But now, this number of moles is in the new volume of 30, right? Okay, so let's cancel out the 1,000. 10 plus 20. Okay, this is the 10 from the acid. 10 Cn cubed, CH3COH, and 20 Cn cubed, NaOH. Okay. So the 1,000 we cancel out. You want to cancel out the 10 also can lah. Okay, work out your math faster. My God, stop texting me. Don't wish me, thank you. Okay, this one is a square I left out. So now we can find POH, right? Can or not? Can, right? POH what? Negative log. Okay, I make OH minus the subject. Okay, so 10 to the power minus 14. 10 to the power minus 14 divide by 5 times 10 to the power minus 5. Right? This is my KB. Right or not? Then I move this entire value up here. Right or not? So times.
Miss Claire, can move up a bit. Yes.
Okay, times 0.2 times 1/3. Okay, this one here, 0.2 times 1/3. I move it to the left-hand side of the equation. Okay? Then this whole thing need to square root or not? Right or not? Compute now. You all see can get answer. And this one is number 3, salt hydrolysis. 0.56.
You have to put 14 minus, I think. Because it's a pH.
You all get it?
Mm-hmm.
Okay, so this is the third one.
Wait, we have to copy the whole thing down.
如果你 own 咯，都 copy 啊。Don't copy 啊，just 弄你 own。
Remember until which part? Like from which part I
From the baby. You ask me I think this line enough already.
so I was thinking
Okay, well.
If you ask me I think this one enough. But that's me Later you all see wow, where all this number come from? You go back and revise and shit, don't understand. Among all, number 3, salt hydrolysis is the hardest. This one is the hardest. This is usually worth about 3 to 4 marks. Yeah.
oh
That's all. You rather describe the trend of the periodicity from Describe the melting point trend from sodium to argon.
Mine.
Which one you rather? You want 4 marks for this or 4 marks for that description? Okay, so this one is the third one, the salt hydrolysis. Okay, we will be repeating this another 3 times in different scenario. So you all will get the hang of it. Okay? Okay. Okay, last one. At 1.5 V. Okay, so now I have extra top up already. Okay, I add more.
Then does it become number 2?
No, it's the last one yes, number 2. Last one I haven't teach you all. Okay, strong acid and base in a new volume. Okay, so at 3/2 V, right, I have half V excess. Right? Okay, so at 3/2 V, okay, we have half V excess, right? So we need to find the pH. Is it pH, right? Okay, I find pOH first. Okay, so I have how many moles of excess NaOH? I have 5 CN3 excess, right? Is it? No. How many CN3 excess I have? Half V is 10, right?
Yeah.
Yeah, so I have 10 CN3 excess. Okay, the number of moles is 0.1. Okay, or 1000. This is my number of moles of excess NaOH. So far you follow? Then it's in a new volume. Yeah, better put OH minus. What's the new volume? Okay. Convert of 20, 10, 30, 40. Okay, can. Okay, so we cancel. Now that you have your concentration of OH minus, I let you all do this on your own. Find the pH. You got it? 12.4, right? Uvia, did you manage to get 12.4?
Yes. Yes.
Okay, Okay, the last bit is over here. Okay, the indicator you need to use. Okay, the word is phenolphthalein.
Have you spelled phenolphthalein? Okay, let's spell it.
Okay, you all need to learn this word phenol because you will learn in organic chem. Okay, phenol is this compound that looks like that. Yes. Okay, then phenol, you're trying to find the pH, right? So got one pH behind. Okay, then phthalate. So cute, right? My handwriting. So neat, like primary school kid, like a very neat primary school kid, right?
Where do you want us to write?
Next to the word colorless to pink. Okay, so just remember, in general, when you use a strong base, right, your indicator you need to use is phenolphthalein. Okay, unless question give you other options, but usually we use phenolphthalein. Okay. So we finished the first column. Oh, not yet. Still got one bunch, but the graph. The graph. Then close already. Very easy. The graph very easy. Really. Last bit. Okay. The graph looks like that. This one has a buffer at the beginning, right? So okay, just sketch this and then just fill in the value. Your initial pH is 2.5, so just fill in 2.5. Then your quarter V, see this part here, this is V. Okay, this is V, this is quarter V, and then this is half V. Okay, this is quarter V. Okay, so quarter V, you have 3.82. Half V, you have 4.3. Your V, which is your equivalence point, you have 8.56. Okay, then you have a 3 over 2V at the end. Okay, this one is 12.4. That's it. Then just label this is pH. This one is volume of NaOH. Okay. So some things to take note of, okay, is that, okay, I'll let you all finish drawing first. Ubia, let me know when you're done drawing. You will get the paper from Shu lah. Then you can transfer your writing over. I'll also upload the video if you all need to rewatch to transfer onto the chart. Okay, listen up. Okay, when you have a buff, usually right, your titration curve right always involve one thing strong and one thing weak. So you can have a strong acid weak base or a strong base weak acid. Okay, but you can also have them interchange in the sense that one of them go into conical flask, which one go into the burette. So if you do the different combination, there are 4 possible outcomes lah. Okay, correct or not? Okay, so today we did the one where here you have the strong base. Here you have the weak acid. They can also interchange. The graph will come out differently. Understand? Okay. So, so in this case, right, if you interchange, my buffer is at the end, not at the front. It will be the after equivalence, then you form buffer. But in this case, our buffer is here. Okay, this is your buffer region. Okay, this part is your buffer. Okay, this part here is called your MBC. Okay, maximum buffer capacity. Okay, and since you are using a strong base, it's likely that your salt undergo a basic or alkaline hydrolysis. Hence, you notice that equivalence point is more than 7. Okay. So these are just some points you need to take note when you are doing titration curve. Okay, there are 3 more curves to sketch, so I will run through them again 3 times. Okay, you do the same thing 4 times, you should be very good at it really after that. Okay, if no question, then that's all for today. Wow, today lesson very long, 2 hours and 18 minutes. Okay, so I will continue this on Friday and I'm going to stop recording now.